Welcome to Maths and Science by IITIAN channel. In this lecture, I will be discussing about one very good example on Diophantine equations and set theory to represent this particular Diophantine equation in a set builder form, and also to discuss the Fermat's little theorem and factorization identity, sum of two squares representation, and it's a very good example where a to the power of n plus b to the power of n is equal to c to the power of n. As per Fermat's theorem, it is only valid for n is equal to less than 2, less than or equal to 2. It cannot be valid for more than 2. Now, what we wanted is that a to the power of 4 plus b to the power of 4 is equal to 2657. We have to see whether 2657 has any factors. Is it a prime number? Not a prime number? Then we have to proceed to find out a square plus b square is equal to how much. Only one equation in square of 4, and we have to find out the value of two unknowns, and where this particular problem how to be represented in a set builder form, so that in sets also, in set builder form also, if the question is given, how to solve it, that also we will be discussing. Set builder form. This example will be very useful for JEE Mains, for CBSE, for Maths Olympiad. Very good example. When a to the power of 4 plus b to the power of 4 is equal to 2657, what is the value of a square plus b square? It is what we are going to find out. Let us go further. We will be solving it using the number theory and also algebraic identity, and we will be using the factorization identity and sum of two squares representation. We will be using all of these concepts, and one by one these concepts will be explained along with the problem solution. Let's now move further. What is the problem given? Question is a to the power of 4 plus b to the power of 4 is equal to 2657. Find a square plus b square is equal to how much? When it is a Diophantine equation. Diophantine equation. Diophantine equation means a and b are integers. That means if a and b are integers, when their sum is a to the power of 4 plus b to the power of 4 is equal to 2657, we have to find the value of a square plus b square. How to write it in set builder form? First question, how to write it in the set builder form? Solution. A to the power of 4 plus b to the power of 4 is equal to 2657. That means function AB is equal to a to the power of 4 plus b to the power of 4 minus 2657 is equal to 0. Then, what is the condition? A, it is a Diophantine equation. That means A, B are integers. These are the two conditions. Here, A, B are integers. It's a Diophantine equation. Now, how to represent this in a set builder form? In a set builder form, let us be a set where function AB are such that, please try to understand me, a to the power of 4 plus b to the power of 4 is equal to 2657. You can either say this is a Diophantine equation, or another condition you can put as AB integers. AB integers, or we can say Diophantine equation. We can even write it like this: S is equal to function AB such that a to the power of 4 plus b to the power of 4 is equal to 2657, Diophantine equation. So that a function is so and so, then the values of a and b are the solution for this function, and they are the number of elements. Then we can call cardinality of S is equal to how much? In a set builder form it can be like this also. And once you have a square plus a and b, a square plus b square is equal to how much? This is how in a set builder form a question can be asked. A question can be asked in this way also. Either way the question is valid. Now let us try to solve the problem. We have defined the problem. Now let us try to solve the problem. You can solve it algebraically using all algebra identities. You can solve it using number theory, congruence modulo. I will use the number theory, congruence and modulo, and you can extend your knowledge by applying your algebraic formula also. Now, what is given here? A to the power of 4 plus b to the power of 4 is equal to 2657. Is 2657 can be something like c to the power of 4? Is it possible? No, it's not possible. Hence, as per Fermat's theorem, a square plus b square is equal to c square can be possible, but a to the power of n plus b to the power of n is equal to c to the power of n for n greater than 2 is not possible. As c to the power of 4 is not equal to 2657 for any integer value, this implies from number theory solution is possible. First, we have checked whether it is possible or not. A to the power of 4 plus b to the power of 4 is equal to 2657. Now, let us try to solve it. Let us check for modulo 16. What is the equation given? A to the power of 4 plus b to the power of 4 is equal to 2657. Let us take right hand side value. 2657 is equivalent to how much? Mod 16. You just see 0 to the power of 4 is equivalent 0 mod 16. 1 to the power of 4 is equivalent 1 mod 16. 2 to the power of 4 is equivalent 0 mod 16. Because to the power of 4 is there, we have taken mod 16. 3 to the power of 4 equivalent 1 mod 16. Similarly, up to 15 to the power of 4 is equivalent to 1 mod 16. This particular series shows that for any value of a and b, integer values, a to the power of 4 plus b to the power of 4 is equivalent to 0, 1 and 2, because these are the values which are getting repeated. Mod 16. Because a to the power of 4, 0, 1 up to 15, b to the power of 4, 0, 1 up to 15, that means 1 plus 1 is also 2 we have to take, 0, 1, 2. These values can be 0, 1, 2. That is the reason why 2 has come here. Now, but we have that a to the power of 4 plus b to the power of 4 is equal to 2657. Now, a to the power of 4 plus b to the power of 4 is equal to 2657. Then 2657 is equivalent to what mod 16? When you divide, that means when you divide 2657 by 16, what will be the remainder? Let us see. 2657 divided by 16 is equal to how much? Just see. 2657 divided by 16 is equal to 166 plus 1 as a reminder. Please see. Then what is the value of this? This is 1. That implies 2657 equivalent to 1 mod 16. And a to the power of 4 plus b to the power of 4 equivalent to 0, 1, 2 mod 16. From these two also, we can say solution exists. Now, that means we have established that there will be a solution that exists for a to the power of 4 plus b to the power of 4 is equal to 2657. From both the Fermat's theorem and also from sum of squares, that is a square plus b square is equal to a to the power of n plus b to the power of n is equal to c to the power of n is not valid if n is greater than 2. That we have proved that n is c to the power of n, that n is greater than 2 is not existing, because c to the power of 4, there is no c to the power of 4 for 2657. Hence the solution exists. Here also 2657 equivalent to 1 mod 16 and a to the power of 4 plus b to the power of 4 is given as 2657, which has 0, 1, 2 mod 7 mod 16. Hence the solution exists. Now next step. We got that solution exists. Now a to the power of 4 plus b to the power of 4 is equal to 2657. Now let us see whether it is a prime. Primality of 2657. Just check up. Square root of 2657 is equal to 51. That means any number less than 51 prime, we have to divide and see whether it is a prime number or not. What are the primes? Below 51, 2, 3, 5, 7, 11, 13, 17, 19, 23, 29, 31, 37, 41, 43, 47, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. To check with these numbers is not a big task, and we conclude that 2657 is equal to a prime number. That means a to the power of 4 plus b to the power of 4 is a prime. Some prime number, that is p, that is equal to 2657. From Fermat's the sum of two squares theorem. That implies from sum of two squares theorem, another thing also you see, 2657, we are going very step by step, very carefully. 1 mod 4, just check up. Because 2657 by 4 is equal to 664 plus 1 remainder. When it is 2657, some number is equivalent to 1 mod 4, prime number. That means P is equivalent to 1 mod 4. Two six five seven P is equivalent to 1 mod 4. That implies It is a sum of two squares. It is another theory. Another theorem of number theory. That implies a number m square plus n square is equal to 2657. This is what we have got ultimately after the number theory. Let us try for 50 square. 50 square is 2500 plus n square 157 is equal to 2657. Is 157 is not perfect square. That implies this is also not possible. Next, let us go for 49 square plus some n square is equal to 2657. Here you see another shortcut I will tell you. Another method. M square is equal to a to the power of 4. That means a square to the power of 2. A square square. N square is equal to b square square. That is b to the power of 4. That implies the value with m is equal to a square, n is equal to b square. That means m and n should also be perfect squares. Are you able to follow? That means m and n cannot be more than 51, we know. M and n cannot be more than 51. Below 50, how many squares are there to accommodate for m and n? How many squares below 50? One is 7 square, that is 49. Another is 6 square, that is 36. Because 8 square is more than 64. Another is 5 square, that is 25. Another is 4 square, that is 16. Another is 3 square. Another is 2 square and 1 square. Now, m can be 7 square. That is m is equal to 49, 36, 25, 16, 9, 4, 1. That means for m and n values we have to check only out of 50, we have to check only perfect squares, that is 49, 36, 25, 16, 9, 4, 1. Now, let us say m is equal to 49. Then we have the equation that m square plus n square is equal to 2657. That's what we have got. M square plus n square is equal to 2657. That implies n square is equal to 2657 minus m square, that is 2657 minus 49 square, that is equal to, what is the value of 49 square? 2401. 2657 minus 2401. What is its value? 256. 256 is 16 square. That means m is equal to 49, n is equal to 16. then this particular equation of m square plus n square is equal to 2657 is satisfied. And the reverse of this 49 and 16 and 16 and 49. Now we will remove that pair. What are the remaining? We have to check. Only three values: 36, 25, 9, 4, 1. In this, let us go for 36. M is equal to 36. Then n square is equal to 2657 minus 36 square. That is equal to 1361. 1361, is it a perfect square? It's not a perfect square. N square is not a perfect square. Hence, this answer is not possible. 36 is gone. Now 25. And afterwards, lesser values we need not see because we have already seen the higher values. Now 25. M is equal to 25. N square is equal to 2657 minus 25 square. 2657 minus 25 square. 2032 is not square. Hence, it is not possible. It's not a perfect square. That means n is not an integer. And n is nothing but b square. N should be a square. N square from n square, when you get n is not a square. Hence, the only solution, unique solution, m and n are interchangeable. So that don't worry about either a, m or n. That is interchangeable. Mn is equal to 49 and 16. That means m is a square, n is b square, is equal to 49, 16. That means only unique solution for a square plus b square is equal to 49 plus 16 is equal to 65. This is the only unique solution we have. Even if we interchange, for example, 16 and 49, a square plus b square is unique. Either you add 49 to 16 or 16 to 49, the value is unique solution. This is the unique solution. And what we have discussed here, one is a to the power of n plus b to the power of n is equal to c to the power of n, not possible for n greater than 2. That is what we have understood or what we have used. And another thing is sum of two squares. If sum of two squares is equal to p, that is a prime number, p equivalent 1 mod 4. This also we have used, and we have used another one also, identity congruence. Some number a to the power of 4 is equivalent to 1 mod 16 when a is 1, 2, 3 up to 0, 1, 2, 3 up to 15. This we have used. Congruence modulo 16. That means these are the principles on which we relied for the solution, and we got an unique solution, that a square plus b square is equal to 65. This is our solution for a to the power of 4 plus b to the power of 4 is equal to 2657, where 2657 is a prime number and it is representable as sum of squares. And with this I want to conclude this lecture. Thank you for seeing my lecture. Thank you for listening to me. Best of luck to everybody. If you feel there is a value addition to you because of this lecture, kindly hype this video, kindly share this video or lecture to known people to you, and kindly subscribe to my channel Maths and Science by IITIAN. This type of problems you may come across in Maths Olympiad, IIT JEE Maths Mains, IIT JEE Advanced Mathematics or CSIR Mathematics. Best of luck to all of you. Thank you for listening to me. Kindly share and subscribe to my channel Maths and Science by IITIAN. Thank you.